So let's kind of sum this up with some in behavior and asymptotes of rational functions. Just kind of talk about, in summary, some of the stuff that we looked at. So suppose f of x equals p of x over q of x is a rational function where both p of x and q of x are polynomials that have this form. We've looked at this form before. And bn, both am and bn are non-zero. The leading coefficients for both p and q are non-zero. Then, if m is less than n, so if the order of the polynomial in the numerator is less than the order in the denominator, then the limit as x goes to plus or minus infinity will be equal to 0. And y equals 0 is a horizontal asymptote. We've seen that in an example or two. If m and n are equal to each other, then the limit as x goes to plus or minus infinity, we end up with a horizontal asymptote. That's equal to the ratio of the leading coefficients. We saw that too. This I made mention of. This is a typical sort of thing you did in pre-calculus. But if you actually take the limit, you will show where that pre-calculus or what you did in pre-calculus is actually a calculus result. Now, if m is greater than n, so the order of the polynomial in the numerator is greater than that of the denominator, then we're going to end up going to plus or minus infinity. It's going to blow up on you. And in fact, f does not have any type of horizontal asymptote. Now, right here, we talk a little bit about the idea of vertical asymptotes. If the function f is reduced to lowest terms, that means that all the common factors have been factored out and canceled, then a vertical asymptote will exist for any value of x such that the denominator is still 0. Very common example would be like x squared minus 4 over x minus 2. Right, if x equals 2, I have an issue here. I get, 0 over 0. That's indeterminate form. But this is x minus 2 times x plus 2 over x minus 2. These cancel out. I do not have a vertical asymptote. This just looks like x plus 2. But if I switch these around, then I have in the numerator x minus 2 over x minus 2 times x plus 2. These will cancel out, and I end up with, I'm going to come over here, 1 over x plus 2. Well, everything's been canceled that possibly can be. So when x equals negative 2, the denominator is 0, so I will end up with a vertical asymptote. So you may want to spend a little bit of time looking at all this. It's just kind of a summary of everything that we've been doing here in terms of in behavior, looking at horizontal asymptotes. But again, you actually need to take the limit. You can't just say, well, I'm looking at this exponent, that exponent, so it must be that. I want to see you actually take limits.